Okay, in my last video, I left something out. Okay, I was trying to justify the comparison test. And remember, I said this sequence, SN, is convergent. Okay, that's what I was saying right here. The sequence SN is convergent. That's what I was saying. That's what I meant when I said it's convergent. What I meant was this sequence SN is convergent. And I should be adding here. So add this to your notes. Therefore, summation n is convergent by definition. That's the definition of the convergent series, is that the corresponding sequence of partial sums is convergent. Okay, let's do another example of something actually divergent. Example. Summation ln of n over n. So I should probably start at n is equal to 2 here. Okay, I don't want my first term to be 0. That's awkward. A little bit awkward. So why is this divergent? Well. Let's see. So this is a less obvious comparison. So I look at ln of n over n, and I say, well, this is 1 over n, right? But bigger, right? Because I got the ln n on top. So, okay, this relies on some knowledge here, right? I know that in my mind, I'm thinking to myself, summation 1 over n is divergent. Okay, this is like in my toolkit that I have close to hand. So because I know this thing in red, it helps me understand, what comparison I should be making. Okay, again, it's a tool. If I don't fill my toolkit, memorize these things, then I'm going to have a tough time coming up with these inequalities, which are tricky sometimes. So here's my argument. Ln n over n is bigger than 1 over n. Is it always? Wait a second. It isn't, right? But because if I put in ln of 2, if I put in n equals 2, then I get, that's less than 1. So this is an important point. So this inequality is true, we say eventually. Meaning past a certain point. So for n, in this case, if it's n is bigger than 2. So even though the theorem says, what does it say? Does it say eventually? Oh, yeah, I use the word eventually here. I do use the word eventually. Okay, that's good. So what I mean by eventually is that, past a certain point, this inequality is true. And that's good enough for a comparison test. Actually, this is going to be something you can use a lot, useful when you're using integral tests too. Anyways, back to what I was talking about. So I got my inequality. Oops, not that down. I don't want that. I want 1 is divergent. Since p is equal to 1, which is less than or equal to 1. Okay, so my series is bigger than something divergent. So that's the way I think of, that's the easiest way to think of a comparison test. So summation ln of n over n is divergent by comparison test.